Hello everyone. In this video, I will continue with the previous lesson of finding Fourier series of the square wave. And because I could only set the video to be 30 minutes, and it's kind of cut off in the middle of what we did. And just to remind everyone what we have done in previous video is that we have the introduction to our square wave. Fourier series of a square wave consists of the sum of all the sinusoids, and we got here like we have only one wave, we have the addition of two waves, we have 5 terms, we have 14 terms, we got 20 terms, we got 26 terms, we got 36 terms, until we get 50 terms. And if the more terms we have, you see this line right here will turn into a straight line. Okay, and in this case we are having a square wave, right? And the square wave is the sum of all the sine wave that we have, and we can prove it here. And we put value into this square wave. We put 1, we put -1 as a function fx. We have to figure out the Fourier series with 5 terms. And before we do that, what we do is the functions are given to us. We know that it's a split function, so we have to identify the two periods. And this function is given to us as odd and halfway symmetry. When it is odd, then when you don't have a constant term, you don't have a cosine term, the function is odd, you only have the b term, which is in this case is the bn, and this is halfway symmetry, therefore you can only have the odd harmonics, so you can only have the odd coefficient b. Okay, so to calculate this, what you need to do is we need to use the formula bn equal to 1/pi integral from -pi to pi of the function fx sine nx dx. Because it's a split function, so you have to have the sum of these two integrals. And in integrate these two integrals, we apply the fundamental theorem of calculus, and we are using some formulas that I identify for everyone on this page. Okay, so in the workbook that we use for this class, I would like everyone to concentrate on page number 11, page number 12, page number 13, and page number 14. And on these 4 pages, you will find some formula that you may need in order to apply to your integral. Okay, because we integrate by using unspecified term n, therefore we need to use those formulas to help us. So one formulas we need to use is we have to figure out sine of nx. Okay, so the best is to use that shortcut that I show you, and from that formulas I turn that into negative cos of nx over n, and the same thing here. And I simplify, I apply fundamental theorem of calculus, evaluate from the upper limit minus the lower limit, and I end up with the unspecified term n as bn equal to 4 over n times pi. Okay, so now at this point, what you need to do is you are going to write b1 equal to 4 over 1 times pi. Alright, okay, b3 will be equal to 4 over 3 times pi. b5 will be equal to 4 over 5 times pi. b7 equal to 4 over 7 times pi. And b9 is equal to 4 over 9 times pi. So these are the 5 Fourier coefficients that you found from integrating, and you find the final answer for the bn. Okay, because I'm asking you to find just 5 terms, so you are going to pull out the 5 Fourier coefficients. Okay, but we have to write it in terms of Fourier series. Okay, so Fourier series is just simple as fx. Alright, okay, so first of all, you have the b1. So let me go to our formula sheet and I will find the reminder of how I should write it in terms of Fourier series. Okay, so you see that Fourier series given as f of t, okay, f of t, or f of x. In this case, I should say f of x. Okay, so f of x equal to, we have this term, and we should have b5 sine of 5x, b7 sine of 7x, and b9 sine of 9x. Okay, so because all of this term was already eliminated. Okay, all right, so let's go back to our chart here, and we are going to write it as 4 over 1 times pi, this is b1, times sine of 1x. Now b3 is 4 over 3 times pi times sine of 3x, plus 4 over 5 times pi times sine of 5x, and then plus 4 over 7 times pi sine of 7x, plus 4 over 9 times pi sine of 9x. And what I will do next is I will factor out 4 over pi. Okay, factor out 4 over pi. What I have left in the bracket should be sine of x plus sine of 3x over 3 plus sine of 5x over 5 plus sine of 7x over 7 plus sine of 9x over 9, and close the bracket. So these are the 5 terms of this Fourier series of the square wave, given the square wave is odd and halfway symmetry. Okay, so let's go back to our first page. Alright, okay, so on the first page, what I basically did for everyone is we are finding this term right here, there, and there. Okay, so we are finding the 5 term for this Fourier series, and you see now it's proven that the more terms that we have, that we add them all up, it turns into a straight line. Okay, so in a way, square wave is the sum of all the sinusoids. Okay. And what kind of sinusoid we have in this case? It's just the sine, and it's also just be the odd harmonics. Okay, so I would say here odd harmonic. Alright, thank you.